The next team to present is Team Dynamic from UKM.
To the most honorable judges, my name is Nur Farahuda. This is my teammates, Siti Aisha and Nur Hafiza. We are from Department of Mechanical Engineering from the Faculty of Engineering and Built Environment of University Kebangsaan Malaysia. And today we would like to present regarding to our concept, that is the irrigation system of palm plantations. Okay, we are all aware of the palm plantations' contribution to the world, and today we would like to enhance the system and implies one or two of innovations that by our own idea. Okay, this is our system. This is water tank, power generation, water supply, liquid fertilizer tank, WSN, and pipe. Okay, the water tank will flow into three tanks. That is boiler in power generation system, water supply tank, and liquid fertilizer tank. For the power generation system, the boiler will produce heat. The heat from the boiler will be produced by the burning of oil palm waste. That is 70% of palm fiber and 30% of palm kernel shell. Then the superheated steam will enter the steam turbine and rotate it. The torque produced will generate electricity. The turbine was designed to produce 50 kilowatt of electricity that can be used for the small cabin in the palm and also for charge of the equipment used for palm plantations, and mainly to supply electricity to our irrigation system. Okay, next, this is the water supply tank. It will supply the water to the plantations by taking into account the moisture content of the tank. We'll look about that after this short while. Liquid fertilizer tank. It will supply the liquid gradually. Oh, sorry. And why? Because the faster rate of absorption and immediate effects and good for all range of the pH of the soil. Okay, this is our irrigation system. Can you see? As you can see, this is the wireless system network. Okay, this is the node located for each pipe at each pipe. Okay, this irrigation system will be laid down according to the patterns of the tree being packed. Okay, this is a small vertically pipe that will be inserted 1 to 2 meters down the underground that will supply the water and fertilizer. At this pipe will be located the wireless sensor network node. Okay, this node will have transducer to receive the signal and transmit the data to the gateway. This is the gateway. Okay, this can be controlled by any device such as mobile, the internet, and computer. The nodes will detect the moisture content of the soil and will supply water if the soil moisture content is less than 14.5%. Okay, and as for that, this is our SolidWorks 3D design of our system, and this system is sorry. In a nutshell, the system consists of three main points. That is power generation system, water supply system, and liquid fertilizer tank to supply to the system, to the plantations. This can be seen as to enhance the plant growth of the plant plantations. And thank you.
Palm plantation being planted in Malaysia? Yes. Very undulating kan? They are never on flat ground. Very undulating. In fact, some part very hilly and quite slopey lah in most cases kan. Your diagram show all flat. So you need a lot of pump to pump up the water up and down because of the terrain. No oil pump except for peat. And oil pump on peat is a dirty word. Nobody likes it. And it's the only thing that's flat. But otherwise, they're all hilly. So how do you tackle that?
Okay. The pipe, you're asking about the pipe and according to the structure of the plant, the soil. No. The terrain. Okay, the terrain is very easy. So, not so easy to put sensor and pumping of water, you have to go up the hill.
Of pipes that is on the ground and underground pipe. That underground pipe, yes, it's very hilly, that's why I understand that. But for us to supply the water and liquid fertilizer, it's by using the underground pipe, which is small tubes.
Yalah, tapi atas bukit you need some kind of pump to put in. So have you considered that in your design?
Okay,
Because it's
yes.
not this simple in that sense, because of the undulations
I
and
understand.
because of the slope. You're talking about maybe up to what, 8, 9 degrees, 10 degrees, you know?
Yes, we do have pump, especially in the pipe of the supply system.
I just want to confirm again your whole flow here. Your water in your water tank, which is the first step?
Yes,
This is the water tank. Then it goes to the steam turbine.
The steam turbine, water supply tank, and also liquid fertilizer tank.
So basically, it goes to the condensate after the turbine, or what? So the steam turns into condensate. You condensate it, and then it goes to the tank, and then you pump it out to the field. That's the idea.
No.
No. Okay.
Okay. Would you like for me to
Then
explain?
please
Okay, then.
explain. Yeah.
The water from the water tank will be flown into the boiler. It will
Okay.
boil, and it goes into the steam.
Mhm.
And the steam will be recycled and will be condensate again into water in the condenser.
Yeah.
And it will rotate again. The condenser will supply it to the boiler.
Okay.
Rotate again. As
Okay.
The flow is just inside the.
Okay. So where does the water for the plantation come from?
Sorry, the water.
The water you pump to the plantation. Where's that from?
Is from the water tank that is supplied to water supply tank.
Okay, so you're not recycling the water. The water that you're using in the irrigation is technically clean water. It's not recycled
Yes.
water.
It's the clean
Okay.
water.
Okay.
Rainwater harvesting is an option.
Okay. Okay. So again, that I think brings it down to cost, because again, most plantations actually not need irrigation. Yes, somebody can benefit from it, but this doesn't look cheap. I must say, if you are going to, if you harvest rainwater, okay, you can at least that's an option. If you have to pay for the water, I think the plantations are not going to take it. But building all that piping and making it automized does seem quite costly. I don't know if have you made any cost estimation on how much this would be?
Not yet, technically.
Okay, that might be the first step you do, because if this turns out to cost hopefully not hundreds of thousands, but at least tens of thousands per hectare, then the plantation companies are not going to be too happy when you present that to
But
them.
this can reduce the labor for putting the fertilizer, as
True.
we have the system to make it easy.
True. Okay. Okay. Yeah, I think again it's interesting enough if you can keep down cost and you can prove that you can actually, again, mechanization. I'm all for mechanization in plantations. There's too much manual labor going on. So if you can include whatever nutrients, maybe pesticide, whatever is needed, and put that all into a system, then the potential might be there. But again, this would only be applicable close to the mills. So I mean, most plantations are not like few kilometers, but several kilometers from the mill. So you're going to need a lot of piping for that. So I think your first step is making some financial estimations before you move on. But if you can keep the cost down, it could be very interesting.